Okay, last lesson of the unit. We really did crank this out. So this last one is actually kind of different than everything else we've done in this unit so far. What we did in this unit so far, lots of things ended up being equal, right? What this last lesson is about is talking about the relationships between the angles and the sides in a triangle. Now, I've kind of talked about this already. We've talked about how if you have two sides that are the same, that's going to guarantee two angles the same. If you have three sides the same, that's going to guarantee three angles the same. And so, of course, all sides are different, all angles are different. But actually, it even goes further than that. We can compare the angles to each other based off of the sides. So what you do is, and ignore the numbers here, you look at the side that the angle is across from, and vice versa. So if you look at the first theorem here, again in your notes it says 4.10, we're told this side is 8 and this side is 5. Now what you're focusing on is what's opposite that side, right? So if you guys will draw this here, if you notice 8, this side, is opposite angle C, right? Here's my angle C, walk through the triangle. We'd say that C is opposite side AB. If you want to write that down, you can. C is opposite side AB. So therefore, here's side BC. What angle is opposite side BC? That's angle A, right? Here's angle A. If I walk through my triangle, we'd say A is opposite, excuse my terrible writing, side BC. So because of how big these sides are, now this doesn't actually tell me the measure of the angle, but what it does tell me is which angle is bigger and which angle is smaller. So because AB is bigger than BC, what that guarantees is that C is going to end up being bigger than A. C is the one that opens up to the bigger side, and you can kind of see if you watch my fingertips here, as the angle gets bigger, my fingertips get farther apart, right? So the size of the angle actually correlates to the side opposite it, right? Again, if you see my fingertips, here's a very small angle. I'm going to keep opening up. As I make the angle bigger, my fingertips get farther apart. That's the opposite side, right? So again, we know that C is greater than A because side AB, which is 8, is bigger than side BC, which is 5. Now, once again, I want to clarify here, if you guys are watching, this does not mean angle C is 8. This only means that because angle C is opposite the 8, angle C is bigger. We don't know what angle C is actually. There's a whole other formula we need for that, and we're not going to learn that. But again, we can tell which one's the biggest and which one's the smallest. So in general, the largest angle is across from the longest side. The smallest angle is across from the shortest side. And the same for the medium sized, right? So we'd say this is the medium side. It's across from the medium side angle. Which again is kind of just reiterating that here. So you're not going to do the exterior angle inequality. So if you look at there's one more thing I want to talk through. If you look at the second page of notes, you'll see this one. Again, it's 4.13, but so turn the page, the second page of notes. You got the front page, second page. This is the other thing we're going to be doing. So we call these triangle inequalities. You may not have ever thought about this or never had any reason to, but you can't just pick any 3 side lengths and make a triangle. Yeah, it should make sense, right? If I pick up 2 toothpicks and a plank of lumber, I can't make a triangle out of those without breaking them or cutting them down, right? Those little toothpicks on the end are not going to be able to reach across the plank to actually TP and make a triangle, yeah? So what this amounts to mathematically is that any 2 sides need to be bigger than the other side. So if I add any 2, it should be bigger than the biggest side. Sorry, the other side. Now, yes, what this does amount to is that the 2 smallest sides. So there's all these things here, but if you can summarize this, two smallest sides need to add to be bigger than the largest side. Sorry for my terrible handwriting here. There we go. Okay, so again, we're going to be working with these two things in class. We kind of had a lot to pick apart there. We're only going to do a couple examples, and then we'll bring it back. I'm almost done here in just a second. Okay, so the first example says to write the angles and the sides in order from least to greatest. Now, obviously, to write the angles in order from least to greatest is not hard because the numbers are there. So I'm going to ask you to do that. We have angle J, G, and H. If you could list those in order here, from least to greatest, that's obviously like second 2-year-old work to do, yeah? Go ahead and list those. Well, G is 35, so angle G is the smallest. Then we have angle H, because that's 45. And then we have angle J. You will see this sometimes written as angle G is less than angle H, which is less than angle J. The issue is that less than symbols and angle symbols tend to kind of run together, so I don't like looking at it like this. You can just list them in order here. Again, we could do it in commas, you could do it as a list. This is least to greatest. Okay, now because of that, even though we don't have any sides given to us, we actually are going to be able to know what's the smallest side, what's the biggest side, and what's the medium side, right? So the smallest side is across from the smallest angle. So let's find angle G here. What side is across from angle G? Walk through your triangle. That's going to be our smallest side. What is it? Well, if I walk through my triangle here, that's going to be side HJ. That's going to be the smallest side. Smallest, least, whatever. So then our next side that needs to be bigger than HJ, but still not the biggest, needs to be across from angle H. So find angle H here. What is the name of the side across angle H? I walk through my triangle. That is JG or GJ. We know it doesn't matter, right? Those correlate there, those correlate there. So we only have one more side left, but again, we can see angle J is the biggest side. Across from that, sorry, biggest angle. Across from that is the biggest side, GH. Largest. Now, again, we don't know what they actually are. We don't know the, we don't know if it's 5, we don't know if it's 10. It doesn't matter. What we're saying is guaranteed, no matter what the numbers are, this is the smallest and this is the biggest. So we're going to try that one again in class, example 2. So skip the rest. We're going to skip all the way to example 6. So if you guys can turn in your packet really quickly to example 6, we'll practice that concept more in class. I wanted to try this concept as well, which we will again practice more in class. So it says, can the following side lengths form a triangle? So here's the rule again for if any 3 lengths can form a triangle. What we need to happen is we need, I'm going to type this so it goes faster. We need the 2 smallest sides, have to add, oh my goodness, have to add to be bigger than the biggest side. Specifically bigger, yeah, not equal to. And I'll actually show in class why. It has to be bigger. So what are my 2 smallest sides here? Well, 2 and 2. If this were to make a triangle, yeah, if I had sticks of 2 centimeters, 2 centimeters, and 5 centimeters, these are my 2 smallest sides. Do these add together to be greater than 5? Is this a true statement? Nope, it is not. 4 is not greater than 5. So nope. These would not be able to form a triangle. What would happen is the 2 centimeter sticks would just go, and they wouldn't catch to make the peak for the triangle. So trying it one more time on example 7. Again, identify the 2 smallest sides. They need to add up to be bigger than the biggest side. Is this true here or not? Well, my 2 smallest sides are 4 and 2. And 4 and 2 is greater than 5, right? This is 6, which is greater than 5. So yes, these could form a triangle. Again, those sides would catch and actually create that peak. So I know this is a lot, but we're going to go back over all the rest of the examples in class and try and drill it in a bit more.